Hey everyone, so today I'm going to be teaching you about writing formulas of ionic compounds. So basically, let's say that you have ammonium bromide. So ammonium bromide, ammonium is supposed to be just one of these on the table. So you would look for ammonium, and right there it says that it's NH4 and it has a charge of positive 1. It's going to stay on the table, so don't worry about memorizing it. And then bromide just means bromine, so you would check on the periodic table. Bromide is 1 away from having 8 valence electrons, since it has 7, and it just needs 1 more, so that means that it would gain 1 electron, meaning that it would have a charge of -1. So when you write those out, since these are already equal, so since there's one of these, 1 times 1 is positive 1, and then -1 times one of these, that would be -1. When you write it out, it would just be, since there's only one of each, you wouldn't have to put any subscripts. Subscripts are like the little numbers on the bottom. So you would write NH4, and there's only one, and then BR. So that's easy when they already cancel each other out. But let's assume that they don't. Like for example, magnesium nitrate. Magnesium, if you look on the periodic table, magnesium has 2 valence electrons. And for it to get to 8, it's going to be easier for magnesium to lose 2 electrons than for it to gain 6, right? Because to get to 8. So it's just gonna lose 2. So positive 2. Nitrate, you would look on the table, nitrate is NO3 with the charge of -1. So these don't automatically cancel out. You're gonna have to do something about that. So magnesium has 2, so 2. And for the easiest possible way for -1 to get to 2 is to just have 2 of these. So you would have to multiply all of this by 2. So -1 times 2 is -2. And see, now it's even. Now they can cancel each other out. So Mg, there's only 1 because you only really need 1. And then NO3. And since there's 2 in parentheses, you would have to put the parentheses signifying that all of this, NO3, is just one thing. NO3 parentheses, and then you put the subscript for 2. And that is magnesium nitrate. Now let's do an example that's not in the book so that you can get extra practice. Let's say aluminum and sulfate. Sulfate is SO4 and it has a charge of -2. You would be given the word sulfate and then you would have to look on the chart for sulfate and you would find that SO4 with a charge of -2. Now aluminum, you would check on the periodic table. Aluminum has 3 valence electrons, so it would have to lose 3 for it to get to 8, because it's going to be easier for it to lose 3 than for it to gain 5, So this one has a charge of 3. So these need to be equal, and there's no way, unless you use fractions, for this to equal this, so you're going to have to find the least common factor. And all you have to do is multiply them by each other, so 3 times 2, that's 6. It's going to have a charge of 6, and they're going to be equal, so -6. So what times 3 equals 6? 2. And what times -2 equals -6? 3. So now you know that there's 2 aluminums for it to be 6, and there's 3 sulfates for it to be -6. So when you write it out, it would be aluminum 2, at the subscript on the bottom implies the number of things it is, and then sulfate, which is SO And this is all one thing, so to imply that, you would have to put parentheses around it. And since there's 3, outside of the parentheses you would write 3. And this is aluminum sulfate. Is that good? Okay. Now, let's talk about transition metals. Transition metals will sometimes have random charges, and it's your job to figure out what their charges are. So let's say that there's FeO2. This is an example in the book. So FeO2, you know that oxygen has a charge of, oxygen, if you look on the periodic table, oxygen has 6 valence electrons, and for it to get to 8, all it has to do is get 2 more. So it has a charge of -2. And then iron, that's the charge that you don't know. So now that you know that the charge of this is -2, and this is 2, so -2 times 2 is, that's not right. Sorry. There's 2 and there's 3 of these. So -2 times 3 is -6, right? Sorry for confusing you. There's supposed to be 2 irons and 3 oxygens. And yeah. And then since the charge on this side is -6, then the charge on this side has to be +6. What times 2 equals +6? 3. So the charge of this would have to be 3. So when you write it out, you would write iron, and then in parentheses, that's when you write the charge. So 1, 2, 3, charge of 3. In Roman numerals, so like 1 is the Roman numeral for 1, the Roman numeral for 2 is 2, and so on. So iron 3, this is the charge, not how many irons there are, and then oxide. Okay, now let's work backwards. So let's say that you're given iron 3 oxide. You know that it's iron, and you know that it has a positive charge of 3, and then you also know that there's oxygen, and you know that oxygen has a charge of -2 just by looking on the periodic table and saying that it has to gain 2 electrons, all of that. But you don't know how many of each there are. And that's what you need to write the equation, the formula, sorry. So this is what we did. This is like what we did when we did aluminum and sulfate. So it's just the same thing. So what is the least common factor of 3 and 2? It's 6, because by multiplying each other, it's just 6. And this would have to be -6. So what times 3 equals 6? 2. And what times -2 equals -6? 3. So when you write it out, since there's 2 irons and 3 oxygens, you would just write Fe2O3. And that's the formula for iron 3 oxide. Okay, now let's do some examples that are in the homework that we did, just to get extra practice. So let's say that you are given CuSO4. So you know that this is Cu. You would look on the periodic table. What is it? It's copper. And the charge is what you're trying to find out. And then SO4, you would check on the table. SO4 is sulfate. So you would just write sulfate. Also on the table, you would see what charge it is. And sulfate has a charge of -2. So SO4, that's something by itself. There's only one of this. If it had something else, then it would have parentheses, and then it would have something written right there. But since it doesn't, then that means that there's only one sulfate. So the charge of -2 times 1 is -2. And then on this side, We don't know the charge, but we know that since this side is -2, then this side has to be +2. So since there's only 1, there's nothing written here, so if there was 2, it would be 2. If it was 3, it'd be 3. But since there's nothing, then that means that there's only 1 copper. So what times 1 equals 2? It's just 2, because 2 times 1 is 2. So now you know that the charge of copper would have to be +2. Okay. Now that we know that, let's work backwards. Let's say you're given the name of the equation, the name of the stuff, and you have to write out the equation. We did this like just a couple seconds ago, so you should be able to figure it out. So let's do copper to chlorate. Can you see that? Yeah, okay. So chlorate, you would have to look back on your table. Chlorate, you'd have to look for it. It's a huge waste of time. But chlorate, ClO3. And you would check what the charge is, and the charge is -1. So, yeah. And then copper, you know that that's just Cu. So now you have to, and since this is given to you, it's copper to chlorate, you know that the charge of copper, what is it? It's 2. They tell you. The number in the parentheses, or like the Roman numeral in the parentheses, is the charge. So, yeah. So how can a charge of -1 be 2? You're just going to have to multiply by 2. So this one, it'd make the most sense for it to just have 1, so it's +2, and this one would have to be -2. However, the charge is -1, so that wouldn't make sense. So you need to know the number of chlorates that there are. So what times -1 equals -2? The correct answer is 2. So in parentheses, outside you write 2. So you would write out the equation. So you only really need one of these, so you write Cu, no subscript because you only need 1, and then ClO3. ClO3 is chlorate, but you don't want to confuse people, so you want to put the parentheses around it, implying that this is just one thing, and then once you have the parentheses now, you have to write how many there are, and there's 2. So CuClO3 2 is the same thing as copper to chlorate. Copper in this formula has a charge of 2. And that's how you write formulas for ionic stuff. Thank you.